Engineering school teaches you the fundamentals of the real world and how to land that first job. What school doesn't teach you are the practical lessons about the practicing of civil engineering. One of the most practical lessons that you don't learn in school is the real world is not a perfect place. And the real world doesn't work in perfect numbers. Let me give you an example as a structural engineer. In school, you get the loads on a beam, and the answer comes out to almost perfect answer of use this side beam to carry that load, or use this many screws to transfer the force. In the real world, you're dealing with a lot more variables, such as space limitations from an architect. You may be limited to a certain material that the contractor already has. You may be dealing with an unknown load or unknown material or any number of unknown variables, and you might have to do research to find these unknown variables. The point is, the answer is not always as straightforward as it's made out to seem, and oftentimes you have to make an educated guess, or in engineering terms, an engineering judgment.
I defer to your good judgment, Captain.
This is oftentimes where experience comes to play, where an older engineer will tell you you should have done this or use this or find this resource. The good part is school definitely trained you to do research and to find resources when you need them. So you are set up in a sense.
Set up? Did somebody say set up? Who am I setting?
Another common mistake that young engineers often make is the practicality of a design. In the real world, you need to consider ease of installation. Let me give a few examples as a structural engineer. Can you fit 6 bolts on a 6-inch beam? Is it possible to get a 100-pound per foot beam to the top floor of a building? Is it possible for a welder to even weld a 1/4 inch with the space that you're given between all the joists? In every case, there are many variables that play a factor, large or small, and they all must be considered. School teaches you the fundamentals of the design, but practical engineering requires understanding of that design and understanding how it's going to be installed. A lot of engineering judgment comes with experience, and you'll pick it up as you spend more time in the industry. A helpful tip to avoid this mistake is think, how would I build this if I was in the industry or outside in the field doing the work?
So, what you think? Super glue or duct tape?
In school, you're taught to get the perfect design. That's exactly what the professor was asking for. In the real world, though, time is money, and the longer you take designing, the more that is going to cost. Sometimes it's worth over-designing something, specifically when the material isn't expensive, like an extra bolt or a slightly larger pipe. If you're wondering how you getting a perfect design affects the owner or the people in the field, think about this. If you spend an extra day doing a design to get the most perfect design ever, that is one extra day that everyone in the field has to wait. Because every day that you are spending doing this design is another day that the entire construction site potentially is being held up. And also remember that engineering is a collaborative effort. So if you're taking an extra day, the architect does also have to wait a day, and everyone else involved also is waiting that day. And this may delay everyone's schedule.
Well, we're waiting.
I'm not discouraging doing good engineering. I'm simply explaining why conservative design is sometimes more efficient. I hope these helped you become a better engineer and helped show that you can be right all the time. It's a terrible outro. And will help you become the best engineer you could be.